Okay, so our last day together in class, I gave you this example to work on, and then we ran out of time before the bell. So the question was, light strikes a photoemissive surface whose threshold wavelength is 720 nanometers, so lambda O is 720 nanometers. The electrons emitted have a wavelength of 2.09 nanometers, so lambda of the electrons, 2.09. And then the question is, what is the color of the light? So to find the color of the light, you need to find the wavelength of the light. Okay, so you're looking for the wavelength of the photon. And then you'll look in that little chart on the multiple choice sheet I gave you to find the color. Okay, so starting with the 720, we can find the frequency, threshold frequency, because we know C equals F lambda. So FO is going to equal C over lambda O. So 2.9979 times 10 to the 8th meters per second divided by 720 times 10 to the negative 9 meters gives us an FO of 4.16375 times 10 to the 14th hertz. So this is my FO. From this, I can find my WO, because WO is equal to HFO. So 6.626 to the negative 34 joule seconds times 4.16375 to the 14th hertz, and you get a WO of 2.7589 times 10 to the negative 19 joules. Okay, so this is my WO that we'll be using shortly, but not yet. First, we need to find the speed of the electron, right? So where we're going is to EK max is equal to HF minus WO. So we have our WO, we want our F so that we can get the wavelength, but first we need our EK max. To get our EK max, we're going to need the speed of this electron, which we can find from deBroglie's wavelength. So lambda equals H over mv. So v equals H over m lambda. So 6.626 to the negative 34 joules seconds over 9.109 to the negative 31 kilograms times the 2.09 to the negative 9 meters. Okay, and you're going to get your speed, which is going to be 3.48044 times 10 to the 5th meters per second. With this speed, we can now find the kinetic energy, because we know EK is equal to 1/2 mv squared. So EK is equal to 1/2 9.109 to the negative 31 kilograms times this 3.48, etc., times 10 to the 5th meters per second. I really did keep all squared. I kept all my decimals. I was just going to run out of space there. And when you do this, you get an EK of 5.517084 times 10 to the 20th joules. Okay, so now we're ready for this equation to find our F. So F is going to be equal to EK max, take the W over, plus WO divided by H. So F is going to equal 5.517084 times 10, that's a negative, it'd be a lot of energy if it wasn't, negative 20 joules plus 2.7589 to the negative 19 joules divided by 6.626 times 10 to the negative 34 joule seconds. Okay, on the top, which is going to be like your EP, you get 3.31061 times 10 to the negative 19 joules, and then divided by Planck's constant, 6.626 to the negative 34 joule seconds, And so you end up with an F of 4.9964 times 10 to the 14th hertz. So now we can use that to find our lambda, because C equals F lambda, so lambda equals C over F. So 2.9979 times 10 to the 8th meters per second divided by 4.9964 to the 14th. And when you do this, you should get a pretty number. It should be pretty close to 6 to the negative 7. So 600 nanometers right on the nose. Now go to that chart at the top corner of your multiple choice sheet, and you should see that this is orange. Okay, and there you are done. All right, so just a cool way to link deBroglie and the photoelectric effect. Don't worry, I'll give you one to try on your own.